Good day and welcome to you all. It is my pleasure to be here today to talk about some of the research that have been conducted over the past year or so at South Dakota State University. Throughout this presentation, I hope you appreciate the multidisciplinary nature of this research, since it involves chemistry, it involves data manufacturing, and a little bit of chemical engineering, all with the idea to recover phospholipids from dairy byproducts. So firstly, I want to acknowledge the work done by my PhD student, Kabir Ranakumar, who has been behind the scenes and doing the experiments in this work. For this presentation, 4 points I will call attention to. I want to start by stressing the relevance of phospholipids, how the phospholipids are become more relevant. And secondly, I'm going to talk about the approaches currently used for taking advantage of these materials, for instance, isolation versus concentration of phospholipids and why there are difference and the relevance of this. And then I'm going to introduce and talk about the methodology we're using here. And finally, I would like to share some thoughts of where this research is going. Let's start with those concepts. The term phospholipids refer to our complex lipids that contain phosphorus in the structure, and that are famous for their polar head and their non-polar tail. Their structure provides several functionalities in terms of processing, as emulsification, for instance, but not only that, it also provides health benefit that has been reported extensively. For instance, they've been associated with the reduced incidence of cardiovascular diseases, also with the cholesterol absorption, and in general, improving immunological functions. So having that in mind that are relevant and they provide health benefit, milk provides a rich source of the phospholipids. Now, the concentration can vary up to 1% of the total fat. That depends on the season, depends on the lactation stage, and many other variables. What is relevant from here is the dairy byproducts, especially byproduct from butter, from anhydrous milk fat contain large quantities of phospholipids because the material has been already concentrated. So that creates a unique opportunity to utilize these byproducts and extract this phospholipid for commercialization purpose. Another relevant advantage or quite characteristics of these phospholipids is the distribution of individual phospholipids in milk. For instance, in milk, the portion of SM and PAs, which is sphingomyelin and phosphatidylserine, is quite high compared to the phospholipids coming from soy or egg, which these two are the two of the most bioactive phospholipids. And so that tells you the milk, especially milk phospholipid, can provide a unique opportunity in terms of health benefits and use as an ingredient in other products, especially infant formula, for instance. Current approaches to obtain, first to isolate those phospholipids. If we want to isolate those phospholipids, the task is not simple. It's a little bit of challenge. If we start as a simplified schematic diagram of how we can isolate phospholipids, we start with the byproduct. If we think about buttermilk, for instance, is wet, is a lot of moisture on it, and the first step needs to be concentrated, and then subsequently uh, combined with solvents, and after several separation steps, extraction, the evaporation, distillation, we ended up with a fraction rich in phospholipids. What the problem with this is there are multiple steps within the entire process. That makes the whole isolation a little bit difficult and challenging in terms of economic. So the alternative for this one is to produce concentrates of phospholipids. And this is, again, a schematic diagram in which we start with a byproduct, most likely already concentrated. And it combined with enzyme, that enzymes they induce proteolysis that helps the separation of phospholipids from the matrix, from the protein matrix. That goes to the next step, which is filtration, And then the retentate containing the phospholipid are further evaporated and concentrated into a concentrated of phospholipid, MPLS, that can contain up to from 20% as high as 75% of phospholipids in that material. There are other technologies has been explored, such as the use of supercritical fluid extraction, simultaneous texturization and extraction, and combinations of microfiltration and supercritical fluid technology. Already in the market, there are products that contain, as low as indicated previously, 20% up to 75% of phospholipids. And mostly these ingredients are used for infant formula. So I try to duplicate the human milk in that sense. What I'm trying to say right now is the phospholipid has a great potential for further commercialization. What we're proposing here is a method that we can extract them, or we can isolate or concentrate those materials by using switchable solvents. The use of switchable solvents is essentially an amine that can be a primary, secondary, or tertiary amine that in nature is hydrophobic as it is, so we can use that to extract the lipid material. And then in the presence of CO2, as indicated in this reaction, the amine is converted into a salt. The salt is water soluble. By doing that, the extracted lipid materials are separated, and then it facilitates the whole process without the need of distillation, without the need or the presence of organic solvents. In this research, we are testing the use of N N-dimethylcyclohexylamine as a switchable solvent. This is a schematic diagram of what we have done in terms of experiments. We started byproduct, we tested different byproducts, buttermilk, beta serum, and concentrated buttermilk. We mix it with different portions of the switchable solvent. After a specific time of extraction, we added water to maintain the stoichiometry of the reaction. Then we added CO2 to convert the amine into the salt, in which at this point, the lipids are separated from the water phase. On one side, we obtain the water containing the salt, and then we remove the CO2 by adding nitrogen here, and we can recover the switchable solvent and potentially reuse that. On the other side, the lipids go to a next step that includes the solid phase extraction to remove the neutral lipids and obtain a concentrate of milk phospholipids. These images indicate how actually looks like the switchable solvent extraction from the step one, in which the mixture of lipids and the mixture of byproduct and switchable solvent. Step two, after a given time, when we added step four, this one after the addition of CO2 is when we can see the lipid at the top of the material that can be separated without the need of distillation. Here, this is what we obtained from an evaluation the total phospholipids in different byproducts. On this side, you see the percentage of phospholipids measured gravimetrically from 0 to 100%. Beta serum is the byproduct obtained from anhydrous milk fat. And here what we used for comparison, we use the Folch method, which is a traditional method that involves chloroform and methanol. As we increase the amount of the switchable solvent, these numbers indicated the ratio 1 to 3, 1 to 6, and 1 to 12 sample to switchable solvent. In the case of beta serum, the extraction was higher with the switchable solvent, but it was not a big impact. It was not that big a difference. However, when we use different materials, for instance, freeze-dried buttermilk, the concentration of phospholipids was quite high using switchable solvent, and even very remarkable, using buttermilk as it is without any pretreatment, up to 99% of the phospholipids were recovered, were extracted with this technology. This is quite remarkable extraction, especially with consider that amount. So that makes us wonder how this switchable solvent works. So this technology rely heavily upon this reaction, upon the amine converted into the respective salt, and vice versa in the presence of CO2. We did test it in the different stages indicated by numbers here, 1, 2, and 3. we measure the amount of nitrogen just to make sure whether if we are not quantified phospholipid amine has a phospholipids. And of course, when we combine the byproduct plus the switchable solvent, the nitrogen content was high. And then after the addition of CO2, there was some remaining amine goes into the lipid phase. However, when after the solid phase extraction, no nitrogen content was detected. So it means there are phospholipids and not amine quantified as phospholipid. Going into more details how this switchable solvent works, this is again the percentage of phospholipids using buttermilk and beet serum or beta serum, and using the traditional metal forge method and the switchable solvent. As I indicated before, the 99% of the phospholipids were extracted, and where the presence of those phospholipids were confirmed by TLC, as indicated in this figure, and we tested also the protein profile by gel electrophoresis. So in this side, we see this side is the standard of proteins, and number 4 represent the B serum, and number 7 represent the buttermilk, the samples without any treatment. As we added the switchable solvent, the protein profile are changing. So it seems there is a reduction of the disruption of the protein matrix that helps the release of phospholipids into the medium, so the extraction can be a lot easier in that sense. We also quantify the particle size by light scattering, and also using confocal analysis, we stain those phospholipids to quantify and see them under the microscope. In the case of buttermilk, the particle size of the untreated sample was about between 570 something nanometers, and this is a representation in the microscope using confocal microscopy, how the droplets of lipid looks like. As we added the Folch extraction, the size of the droplets reduces for around 400, 450. And when we use switchable solvent, that value reduces up to close to 200 nanometers. So it tells you that not only the protein is disrupted, but also the droplets of phospholipids have been reduced. And on this side, you can see a scanning electron microscopy. And this is the buttermilk intact, so untreated material. We can see the protein matrix, how it looks like. When we add the false material, the solvent attack the proteins and release the phospholipids. And when we add the switchable solvent, seems like the protein matrix or the proteins are shrink. There's a shrinkage of the protein that helps to release the phospholipid, and also a reduction in the particle size of those phospholipids. Similar study were observed in beta serum, which is a byproduct of anhydrous male fat, in which the particle size of the intact material or untreated material is around 600 nanometers. And we can see by the size of the droplets under the microscope. As we added the Folch or the organic solvents, the reduction of the particle size goes close to 300 nanometers, and we can see by the image here on the microscope. As we added switchable solvent, the particle size were below 200 nanometers, and we can see by the picture that it's difficult to identify the small particles. And we're also confirmed using scanning electron microscopy here, in which the intact material using Folch and using the switchable solvent, that it seems like the proteins are disrupt. And for two mechanisms are the main, are what we think are the main factors controlling the extraction with switchable solvent. One, it is the disruption of the protein matrix that it seems like it shrinks. It reduces the particle size, and also the droplet size of the lipid is also reduced quite significantly. We also evaluated the individual phospholipid by HPLC, and we had here the distribution of these phospholipids measured by PC, PE, SM, and PS, which corresponds to phosphatidylcholine and the individual phospholipid. Using Folch method, this is the relative distribution, and this is what we obtained using switchable solvents. So the concentration is quite high compared to the conventional organic solvents. If we plot this, one has percentage of distribution. Now I have to be very careful here by saying this is on this side, this graph is a percentage distribution. So the concentration is different and it's a lot higher in the switchable solvent, but this is a relative distribution of the phospholipids. What is interesting here, from B serum, or the beta serum, we obtain high amount of SM, which is sphingomyelin, which is one of the most bioactive phospholipids. And what it tells you here, the distribution is different when we use switchable solvent, and the concentration is different. So it's quite interesting opportunities that this technology can offer for isolation and even concentration and even isolation of those phospholipids for potential use. Now, I want to share some of the final thoughts about this presentation and where we are heading with this research. Firstly, we demonstrated extraction of milk phospholipid using switchable solvents, and the efficiency of the extraction depends on the type of matrix. It works really well for wet matrix, in the case of buttermilk, for a little bit high when the moisture content is quite high in buttermilk. The other matrix we tested is beta serum, or B serum, that total solid is around 20%, and that the extraction efficiency was not that high compared to the wet material. So the extraction, the matrix play a big role in the extraction efficiency. We also demonstrate that the portion of the switchable solvent is not converted into a salt. There's a small portion that either remain as amine, it can go to the lipid phase. However, during the solid phase extraction or fractionation of the lipids to obtain the phospholipid, that was not present. There are two mechanisms by which the phospholipids, the switchable solvent, extract the phospholipid, and one is the disruption of the protein matrix and reduction of the droplet size of the phospholipids. And we also quantify and identify individual phospholipids. So what is next about this is testing different extraction conditions in order to optimize the process, and tested some pre-treatments in order to obtain even higher quantities of phospholipids, and in the case of beta serum, and of course the scaling up of this process. At this moment, this is my contact information. If you have further questions, I will be more than happy to answer by email or during the live session and questions and answers. Thank you very much for your attention.